What if I told you there's a galaxy out there that appears to be spinning the wrong way? Imagine a pinwheel, a beautiful spinning disk of stars, but its arms are leading the charge instead of trailing behind. It's a sight that would make any astronomer stop, scratch their head, and wonder if the universe just broke one of its own fundamental rules. This isn't science fiction. It's a real cosmic mystery centered on a galaxy named NGC 4622. This celestial object, nicknamed the Backwards Galaxy, forced us to question everything we thought we knew about how galaxies behave, presenting a puzzle written in starlight nearly 200 million light-years away from us. It looked like a cosmic rebel, a maverick spinning to the beat of its own drum. The initial shock comes from our deeply ingrained expectations about the cosmos. We see order in the universe, from the predictable orbits of planets to the grand, sweeping structures of galactic clusters. We believe these systems are governed by the elegant and unwavering laws of physics, especially gravity. So when an object as massive as a galaxy seems to defy these principles, it's not just a minor anomaly. It's a direct challenge to our understanding of the universe's architecture. It's like finding a river that flows uphill, or a tree that grows its roots toward the sky. The very idea is jarring. It compels us to look closer, to ask more profound questions, and to find out if we've been wrong all along. This is what makes astronomy so thrilling. It's not just about cataloging stars and planets. It's about encountering the unexpected. The first glimpse of this galaxy is enough to spark immense curiosity. Its arms appear to open up in the direction of its rotation, a feature so rare it has only been confirmed in a handful of cases. This visual evidence alone was a red flag, signaling that something extraordinary was happening within this system. Was it a true exception to the rule, a new type of galactic motion we had never considered? Or was there a more complex story hidden beneath the surface, a cosmic history that created this stunning and deceptive appearance? The stakes were high, because the answer would either rewrite a chapter of astrophysics or reaffirm the power of our existing models to explain even the strangest cosmic phenomena. To understand why NGC 4622 is so strange, you first need to understand the normal way galaxies dance. At its heart is a dense core of stars, and from this core, majestic arms swirl outwards. These arms are not solid structures. They are density waves, much like a traffic jam on a circular highway. Stars, gas, dust move through these waves, slowing down and lighting up as they pass through the denser regions, creating the bright arms we see. In almost every spiral galaxy we have observed, these arms trail. Astronomers even use arm direction as a quick visual shortcut to guess a galaxy's rotation. Then along came NGC 4622, prominent outer arms leading, a faint inner trailing arm, both in one galaxy. So, how do you solve a puzzle like this? You can't just fly out there and watch the galaxy spin. The first step for astronomers was to move beyond a simple photograph and gather more definitive data. The most powerful tool for this job is spectroscopy. By capturing the light from a galaxy, splitting it into its constituent colors, like a rainbow, scientists can see the chemical makeup of the stars and the gas. More importantly, they can measure their motion. This is thanks to the Doppler effect, the same principle that makes a siren sound higher-pitched as it approaches you and lower-pitched as it moves away. Light from the side of the galaxy spinning toward us is shifted to the blue end of the spectrum, while light from the side spinning away is shifted to the red. This technique provides an unambiguous measurement of the galaxy's rotation. It's a direct, physical test that cuts through any potential visual trickery. When astronomers applied this test to NGC 4622, they confirmed its direction of spin. The results were stunning. The data showed that the prominent outer arms were, in fact, leading the galactic rotation. The mystery had just become deeper, because now it was backed by hard data. However, the laws of physics are not so easily broken. The plot thickened when astronomers looked even closer at the Hubble images. They discovered that the galaxy had not one, but two sets of arms behaving differently. While the strong outer arms were leading the spin, a fainter single arm closer to the galaxy's core was doing exactly what it was supposed to do. It was trailing. This crucial detail was the key to unlocking the mystery. The presence of both a leading outer structure and a trailing inner one strongly suggested that two different dynamic processes were at play, likely originating at different times. The leading hypothesis is that NGC 4622 experienced a gravitational interaction, likely a merger with a much smaller dwarf galaxy. Imagine a small boat speeding past a large, slow-moving ship. The wake from the small boat can temporarily disrupt the water around the larger vessel, creating ripples that move in unusual ways. Similarly, if a smaller galaxy plunged through the disk of NGC 4622, the gravitational shockwave could have created a new set of density waves that propagate outwards, forming the leading arms we see today. The galaxy isn't breaking the laws of physics, it's just showing us the chaotic and beautiful consequences of them. Over hundreds of millions of years, these leading arms will likely fade away or reorganize, and the galaxy will eventually settle back into a more conventional, trailing arm structure. This explanation neatly resolves the paradox. The laws of physics remain intact. In the end, the myth of the backwards galaxy was busted, but in the most satisfying way possible. NGC 4622 does not break the laws of physics. Instead, it reveals their complexity and beauty. The galaxy that looked like it was spinning the wrong way was simply wearing the evidence of a dramatic past encounter. The leading arms are not a permanent feature, but a temporary ripple caused by the gravitational indigestion of swallowing a smaller galaxy. This story is a perfect illustration of how science works. A shocking observation leads to a deeper investigation, which ultimately results in a more nuanced and complete understanding of the universe. This cosmic detective story teaches us a profound lesson about skepticism and curiosity. What first appears to be a paradox is often just a clue to a more interesting story. The universe is not required to conform to our simplest assumptions. It is filled with exceptions, oddities, rare phenomena that challenge us to think more deeply. These cosmic outliers are not problems for our theories. They are opportunities. And that relentless, surprising creativity is what keeps us looking up, always asking, why?